Hello everyone, today we are going to continue simplifying radicals. Okay, so just a reminder, a square root expression is fully simplified if there are no perfect square factors of the radicand. Okay, so previous lesson we simplified radicals by finding the prime factorization. Today what we're going to do is we're going to find a list of, or we're going to find the biggest perfect square that divides it and break it down this way. So after today, you'll be able to choose which method you prefer. If you want to use the prime factorization, that's fine. Or if you want to use this list of perfect square factors, you can use this as well. So if we want to simplify using the biggest perfect square factor, here are our steps. First thing we're going to do is we're going to find the biggest perfect square that divides the number. Okay, so we're going to go through a list of perfect squares and find the biggest one that divides it. Write the radicand as the biggest perfect square and the other remaining factor. So we're going to have two pieces and then find the square root of the perfect square and we are done. Okay, so let's check out some examples of that. So first example, we have square root of 28 and a list of perfect squares. So for example, we have 1, 4, 9, 16, 25, and 36, okay? So obviously if a number is bigger than half of 28, then it's not gonna work. So I know that 36 is not gonna work, 25 does not divide 28, 16 does not work, 9 does not work, but 4 does, okay? So if I divide root 28 by 4, I end up with this, square root of 4 and square root of 7. Okay, so this is really the same thing as what we started with. 4 times 7 is 28, so this still means the same thing. So now, since 4 is a perfect square, I can take the square root of it, and that's 2, and 7 is just going to stay inside of the radical. And that's it. All right, next example. So again, I'm going to make a list of perfect square factors. 1, 4, 9, 16, okay? So 16 does not divide it, but 9 is the biggest one that does divide 18. So if I break this thing apart, it'd be root 9 times root 2. The square root of 9 is 3. Root 2 is going to stay the same. And that's it, we're done. Here's another example. So again, perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, and that's all the perfect squares that are smaller than 72. Okay, so 64 does not work, 49 does not work, but 36 actually is a factor of 72. So we're going to break this apart as root 36 times root 2. The square root of 36 is 6. Square root of 2 is just going to stay as square root of 2. So that is our simplified form. Okay, another example. Let me just make the list of perfect squares for us again. Okay, so 64 does not work, 49 does not work, 36 does not work, but 25 does. Okay, so I can break this apart as root 25 and square root of 3. Square root of 25 is 5, root 3 is prime, so that will just stay inside the radical. So that is our simplified form there. Okay, an even bigger number. So again, create a list of perfect squares. So 4 times 4 is 16, 5 times 5 is 25, 6 times 6, 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121. Okay, so there's our list. So 121 does not work here, 100 does not work here, 81 does not work, but 64 does. So this will break apart as root 64 and square root of 2. square root of 64 is 8 root 2. And that is the simplest form of root 128. Okay, another example is just a bigger number, but again, make your list of perfect squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 would be 64, 81 is 9 times 9, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, and 13 times 13 is 169. Okay, so now this does not work, this does not work, this does not, no. 64 does not divide it, 49 does not divide it, but 36 does. 180 divided by 36 is 5. So this breaks apart as root 36 and the square root of 5. So the square root of 36 is 6. Root 5 will just stay inside. And that is now simplified. Sometimes we'll see numbers that are on the outside, and really we're just going to ignore that number for a minute, and we're going to simplify the radical. Okay, so again, make your list of perfect squares. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and 121. And we want to find the biggest one that divides it. So no, 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 no. But yes, 25 does divide 125. And it does it 5 times. So root 25 and square root of 5. And that becomes 5 square root of 5. And then this 3 will just come down. So we have 15 square root of 5. Okay, one more example. Same thing. Make your list of perfect squares. Okay, so when I go through this list, that does not divide it, does not, no, 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 but 49 is a factor, okay? So if I break this apart, it's root 49 times the square root of 3. Square root of 49 is 7, root 3, and then we're going to bring this thing down. Negative 4 times 7 root 3, so that would be negative 28 square root of 3. And we are done there. Okay, so this was just another method of simplifying radicals. Okay, so if you prefer to use this method moving forward, you can use this method. If you prefer the prime factorization method that we learned last lesson, you can use that one. Okay, so please let me know if you have any questions, and have a great day.